Um, Hello everyone. In this morning to still now we are talking about the lot of concepts about deep learning. There are various applications and some technical concepts also. Now, what will we see is a lot of people don't know what is the difference between the traditional programming language and machine learnings. Okay, in this part we will see or we will explore the particular what is the difference between machine learning and traditional programmings. We taken on a simple program. That problem how to find the rules using deep learning. Okay, this we will see in this part. Okay, I just move on to the section. uh, okay, just you see I have some set of numbers, some input values and some set of output values. In case I given the input value is 10, I getting the output value is 14. Okay, I getting some output value is 14. If I given 0, my output value is 32, and so on. Okay, just you think, uh, I just ask you one question to you. While you see this number, in case I given 13, okay, as a input value, what is my output value? Okay, what is my output value? Okay, you just find out the relationship between the input and the outputs. Once you find out, after you given to the input number is 30s, you are getting some numbers. Okay, you just hold on this video, or you just pause the think about this relationship. I given 2-3 minutes to you. Okay, I want what is the relationship? I want to find out this relationship between inputs and the outputs. Okay, okay, I say again. I given input value as a 10. If I given input value as a 10, I getting output value is 14. If I given input value is 0, I getting the output value is 32, and so on. The same like this. I given 10, I getting 50. I given 20, I getting 68. Okay, if I given the input value is 30, what is my output value? Anyone can find out this output value, the 13th corresponding output values? Anyone can do? Okay. mm, uh, okay, if you find out the output value is 86 is correct. uh, okay, now we see uh, the problem how it's solved. Okay, this is the very simple problem, guys. Celsius to Fahrenheit converter. Okay, this everything, the input and output is same temperature value. The inside the temperature you have a lot of things, lot of various units. Okay, Celsius, Fahrenheit, Kelvin, the various units. That is the one of the unit is Celsius. That uh, that values we have as a input. We find out the Fahrenheit value is as a output. Okay, how to solve those problems? Okay, this is a very easy things. uh, Mostly most of the people know these problems. We are studying about our 8th to 10th standard in the science book. Okay, some people is remember, some people is can't remember, but everyone know these problems. Okay, how do you solve this problem? We have two options. One is traditional programming language, another one is machine learning. You just see the traditional programming. uh, I given the input as a Celsius, and I given some rules. Okay, I have some rules also. I given to the computer and I find out the answer in Fahrenheit value. In other hand, I have a machine learning techniques. Okay, I have a Celsius input value, and I have a Fahrenheit as a output value. I have both input and output values, but I don't know the rules. Okay, I just given the input and output to the machine. The machine is find out the rules. Okay, the machine is find out the rules. This is the difference between the traditional programming and the machine learning. Some people may be understand, may be getting the what is the difference. Some people is not understanding these concepts. We talk about very briefly in this section what is the difference between the traditional programming and the machine learning. I just move on to this. You just understand this input value and output value. Okay, this is the formula. Okay, f is equal to c times of 1.8 plus 32. Okay, here f is nothing but f is a degrees in a Fahrenheit value, and it's reference here by letter f. Okay, the c is nothing but c is input value in degrees in Celsius, and representing here by letter c. Okay, this is a very simple. I say once again, f is equal to c into 1.8 plus 32. Here f is nothing but is a degrees of degrees in Fahrenheit. Okay, is represent here by letter f. C is nothing but c is input value degrees in Celsius, and here representing here by letter c. Okay, that's it. Just you assume. Okay, I already talk about this. What is a C? And I already talk about this also. What is F? Okay, here what are the values? I have C values. I have 0, 8, 15, 22, 38, these things. And what are the output values? I have 32, 46.4, 59, 71.6. This also. Okay, here just you think I have 0. Okay, I have 0. I getting 32. How I getting the 32? I just apply to the this equation. I replace the c values as 0. Okay, 0 into 1.8 plus 32. 0 into 1.8. What is the answer? 0. Okay, absolutely 0. What is the now? Now is use equation f is equal to 0 plus 32. Okay, 0 plus 32 is 32. S value is you automatically getting 32. This is a very basic and straightforward problems. Okay, the same thing I given 15. What has happened? Okay, I getting 15 into 1.8 plus 32. Okay, anyone can you help how to multiply with what's the answer? 15 into 1.8. Anyone? Okay, 27, right? 27, yeah, 27 plus 32. Totally the f value, the output Fahrenheit value is 59. The same thing, right? I given the 22. What is happen? I applying this equation, I getting 71.6. I given 38. What is happen? The 38 into 1.8 plus 32, I getting 100.4. It's a very simple and a straightforward problem. How I solve this in programmatically? I have already I know how what are the option. I have two options. One is traditional programming, another one is machine learning. You see, in the what is the traditional programming? I have a input, I have a algorithm, I write on functions. Okay, I write on a function, simple functions. I given to the okay, I pass the some input values, I getting some output values. Okay, it's a very simple thing. You not only you can do any program language. Okay, using Java, C++, C, Python. You have write on simple function. You getting the outputs. What are the things we need? We need input value, we need logic. Okay, these two things is enough, you getting result. Okay, we already know this equation. Okay, in this problem I already find this equation. How I find? I manually calculate this input and output relationship. After I getting these equations, okay, I manually calculate these equations. After I write one function. This is look like a Python. Okay, we are using in the entire programming language, in the entire program we are using the Python language. That's why I given the some example using Python. You can do other programming language is also is possible. Okay, I just write down functions using. I pass my Celsius value in the function. After I write the second line is my logic. Okay, I how I write this logic. I already know this logic. I already know. I already manually calculated this uh, relationship logics. Okay, I just initialize this logic. After I getting the result is f. Here what is c? C is the input. What is f is equal to c into 1.8 plus 32? This is the algorithm. Okay, what is the output? F. Okay, I just passing the input. I just given the 0, 8, 15, 22, everything. Okay, what is happened? The 0 is after come to the equation. The equation is given some outputs like this: 32, 46.4, 59, 71.6, like this. Okay, in other hand I have machine learning. Here I don't know algorithm, but I have input, I have outputs. Okay, I have a pair of inputs and outputs, but I don't know the algorithms. I given to the input and output to the machine. The machine will find out the rules. Okay, here we find out the rules or logic something, but in the machine learning the machine is find out the rules and the logics. Okay, it's happen. How it's happen? Here I the same thing. I have a input, but I don't know the algorithm, but I have outputs. First I given both to the machine. The machine is find out the rules. Okay, after I given the input, after the our previous knowledge, using our previous knowledge, the machine find out the corresponding output, they predict the outputs. Okay, this is happen. uh, okay, this is the same thing. I given input and output to the neural network. I again to again train this neural network. The neural network have some knowledge about this data. After he find out he find some rules. uh, okay. Okay, we already know what is this Celsius to Fahrenheit. The deep learning, this is the regression problem. Okay, this is the regression. The most of the prediction, the I have predict some numbers, I have predict some values. It's a basically regression problem. Okay, there are different type of problems is there in machine learning. Regression, supervised, unsupervised, semi-supervised, you already know. We are talking about the previous class. Okay, that is one of the branches, regression. Supervised learning, one of the branches regression, that is basically predict some values. Okay, we move on. How do okay how we how will we do it this in machine learning? We have Celsius data. We create one neural network. Okay, here we are creating two type of neural network. First we creating one simple neural network, only one layer. That one layer have only one neuron. Okay, we creating another multiple another neural network, the second part, that is a multiple layers and multiple neurons. That multiple, every layer have multiple neurons. Finally we get Fahrenheit data. Okay, we done this problem in different ways using neural networks. Different kind of neural network we will use in these problems. Okay, how will we do this? Okay, you we already talking about lot of thing in deep learning, but we don't know what is the flow of deep learning. Okay, we don't know, right? First thing, the deep learning also have some flow. Okay, the deep learning also some flow. What is the flow? First we understand the data. What is our data? Okay, how is our data? The data is properly arranged or not? Is having any missing values? mm, this data is normalized or have some other things, missing values also is there or not? Is the data have any outliers? These kind of things we will okay, we want to see before the given to the model. In this problem we have very simple, this problem is very straightforward. Okay, we have 4 5 data only. Okay, we have 4 5 data only, and this in this data we don't have any missing values and outliers. This is not, don't have, sorry, it it's not. Okay, the second, first you understand the data, second you creating the model. Okay, creating the model. Once the creating the model is the first, you build the model. Okay, what is your how many layers you have in your model. Okay, in the each layer how many neurons is if is there. Those kind of the basic building architecture, you everything is you did in the creating the model. Once you complete the model, build the model, after you come to the compile the model. Compile the model is find out the your loss and okay, your loss and you optimize your loss. These things everything is happen in a compiling part. Once you done in the model part, after you come to the compile part. The compile part is find out how your model is working, what is the loss. Okay, they predicting the loss. Okay, the actual value to your find out value is predicting some loss function. The loss function also is optimize the same compile part. Okay, once you build the model, complete the compilations also, after you train the model. Okay, train the model is a very crucial thing. Here you initialize what is your input, what is your output, how many epochs also you using, how many times you want to iterate this process. Okay, uh, what is happen actually, my input data is going to my model. My model is learning something, and the learning is I want to evaluate these learnings, how it's my model is learned. After evaluation I want to optimize the loss. This everything is how many times I want to hydrate this process, how many times I want to run this name. I initialize the training part. Okay, I initialize everything in the training part. Once I finish the training part, the model learning is completed, but still I don't know how its model is learned. Okay, how my model is learned. That time I want to visualize the model. Every epochs, I already told, right, then the training, but I have one parameter in the epochs. The every epochs, how my model is learned, I have stored in my training part. Okay, I want to visualize this model. I get a clear idea about my model, how it's learned. Okay, I easily find out this. After everything is fine, I predict, I given to some inputs to my model, I predict the values. This is the flow of this problem. Not only this is the flow of entire deep learning concepts. Okay. mm, Here this uh, creating model to predict the model, this everything is under the deep learning. The first one is not a deep learning, is basically is data how we called uh, okay, the data pre-processing, uh, data visualizing, the EDA part, this everything is covered uh, some concepts. Okay, this everything is doing some other concepts. The 2 to 6 part is completely neural network. Okay, we talk about the coding part now. First, I already told, right, we have creating one model. First model is only one layer and one neuron. How I create this model? I using here uh, layer 1 is equal to tf dot keras dot layer dot dense. Inside I passing two parameters, unit equal to 1, input shape equal to 1. Okay, this is my code. How, what is the code? My model creation code. Here I initialize how much layer I used, how much neuron have only one layer, this everything. Okay, layer 1 is my layer name. Okay, inside this is the I using TensorFlow and Keras library, using creating one one layer. In this layer I initialize two, I passing two parameters. One is input shape, another one is unit 1. What is the input shape means? This is the input data. We already know what is our data. Okay, in our data have only one uh, one column. What is this? Celsius. Celsius is the input shape. That's why I initialize the one. You are okay, unit 1. What is the unit 1? Basically unit is specific the how many neurons in our layers. Okay, every layers have a neurons, right? in this in this layer I initialize only one neuron. Why? This is a very simple straightforward problem, and I have very less data, 4 to 5 5 instance. Okay, this is the enough. Okay, and I want to show something to you, only one layer and one neuron I want to show something. Okay, that's why I initialize this particular model architectures. Okay, once we done with the model creation, after we go to, okay, this also same thing, the model assemble. Okay, what is the assemble? In this problem we have only one layers, but in the normally the deep learning layer not like this. Okay, there are many layers, the many, each layer have many neurons. Okay, so that time we initialize how many layers we used. We want to arrange, we want to assemble those layers in this one model. Okay, that is the tf dot dot sequence. Okay, inside the sequence we initialize every, we assemble the every layers. Okay, that is the very, this is one of the model creating part. The second thing is, once we complete the model creating, we are moving on to the model compilations. Okay, we are moving on to model compilation. This is the yellow thing is my code. Okay, what is the code? Model dot compile. Inside the compile I passing the two parameter. One is loss, I using here mean square error. Another one parameter is optimizer, I using optimizer is Adam. Okay, what is loss? Okay, the loss function is really predict how far to my prediction and I decide outcome from my desired outcome, how far of my prediction value and a desired outcome. Okay, I this calculation is this calculating measure is a loss functions. Okay, this is the I using here loss function is a mean square error. Okay, the second thing is optimizer. Okay, what is the optimizer? I already find out some loss. Okay, I found out some loss, I want to reduce this loss. You just like my loss is 1000, 2000 or 900 or 0.9, whatever I want to reduce to near to zero. Okay, my loss is near to zero, that time only my model is good. I want to reduce this loss. How I reduce? Using optimizer. Okay, the optimizer is reducing our loss. Adjust the internal value. How I reduce the loss? I can adjust the internal values. Maybe I will reduce my loss. This is the possible. Here I using the 0.1. You just okay, you just now uh, okay, you just now this is the learning rate. The learning rate is a small value. Okay, we talk about what is learning rate very briefly in later part. Train the model. Okay, once we finish the model creation and we finish the model compilation, after we come to model train the model. Okay, here I put a one variable name is history. I just store everything about my model model training. I just store everything in the history. After model dot feed, inside I passing three parameters. One is Celsius, another one is Fahrenheit, another one is epochs. Here the first argument is nothing but you already know, this is the input value. The second value is already you know, this is the our output values. Okay, the third one is epochs. Epoch 6, I already set my model architecture. I already set my model loss function and model optimizer in a compilation part. What is happen? I given some datas. Okay, the data is go to the deep learning model. The deep learning model is learn something. The learn something after it come to the loss function. The loss function is calculating the learning terms. Okay, how its model is working. Okay, what is the predicted value, what is the actual value. He find out the some error loss, the loss function after the optimizer they reduce the loss. Okay, this is happen in before. Here I initialize 1000. How, what has happened here? What happened now? This this process is running 1000 times. Okay, the first time is going to the model, compile the predict the loss and optimize the loss. After second time is going to the model, after he predict the loss and reduce the loss after he going is happen in thousand times, is happen is thousand times. The thousandth time is my model is uh, very well. My model is learned very clearly, not very clearly. Is every the deep learning is everything is a trial and error. In this problem, I know I already tried in the thousand time. The model is learned very clearly. Okay, this is the epochs. Okay, once I finish the training, I want to visualize my models. Okay, how it's learned the every hydration. Here you see the x-axis is the epochs, the y-axis is the loss. Okay, we already see in the matplotlib visualization bar, right? The same thing. How we plot this? Plt dot plot of history dot loss. Okay, I just plot this image. I getting this image. You see the zeroth hydration. I getting 7,000 more loss. In the every epochs, I reduce my loss. Finally, in the thousandth epochs, I getting nearly zero to loss. Okay, I can do it. The fit functions. Maybe okay. I clearly about my how it's my model is learned. Okay, the everything is done. Now I want to predict using my model. Okay, how I predict? Uh, okay, this is the code of a predict value. The model dot predict is the one function is there in TensorFlow. We use to this function. We given some input values. We predict some output values. Okay, the model has been trained to learn the relation between the input values and output value. It means corresponding Celsius degree in okay degrees in Celsius and the corresponding degrees in Fahrenheit. Okay, the model is learned relation between these two things. Now we given some inputs value. The model is predict our previous using our previous knowledge. Okay. Okay, this is my overview code. Okay, this is my overview code. First I initialize the layer. My layer name is layer 1. After tf dot I using the TensorFlow obviously. In Keras is another one TensorFlow subdivision. The Keras is running on top of TensorFlow. I using Keras and layer dot dense unit inside the dense unit equal to 1, input should be equal to 1. I have only one input in Celsius. I initialize only one neuron for some in these problems. Statement is enough to one neurons. Okay. The second line is I initialize. I assemble this my layer model equal to tf dot keras dot sequence int layer. Okay. The third one is I want to compile this model. Okay, I using the mean square error and I using optimizer is Adam. Okay, the history equal to I third one is I fit my model. This is the training process. I initialize the input value, output value, and how many epochs, how many times I want to do this process. Finally, I predict some inputs. Okay, here you see I using loss function as mean square error. Okay, optimizer is Adam. Why I using this means there are many. Okay, not only mean square error, mean absolute error also. Mean absolute error is there, mean square error, mean root mean square error, and r square, adjust r square. There are a lot of optimizer is there. Okay, I used a mean square error. This is the standard and one simple one. This the problem also is a very simple statement. That's why I am using this. Adam also is the same. It's a very standard one optimizer. Okay, that's why I am using this. You okay? You just explore the what are the optimizer is there in you go to TensorFlow like Keras official website. There are given the lot examples. Sorry, optimizers documentations. You just go through the documentation. You just use your problems based on some things. Okay, this everything is a trial and error. In the deep learning based, you do everything is a trial and error only. Uh, okay. Okay, once we done this everything in a coding part, we are move on to the second terms. Okay, why we are move on to the second terms means in this okay, we are move on to the second type of model. Most of the deep learning models not like this. Okay, not like kind of not like this. Mostly there are many layers, many neurons. Mostly 90% there are many layers, many neurons. Why? Why we come to the deep learning? The problem statement is very complex, and our data size also is very more. So that's time we using more layers and more neurons only is a correct uh, is a correct way of solutions. Okay, it's a correct things. Okay, why I am here using only one layer and one neuron? I want to show something. We already seen the weights of the only one layers, right? We are compared to with the normal equation to the our getting weights and bias is almost same. Okay, it's almost same. That's why I'm using the only one layer, one neuron. In this real time I want to show something to you, how it's uh, okay, how it's come in real time. Okay, here I initializing two layers. One is first layer is I have five neurons. Second layer is I have only one layer, one neurons. That is output neuron, output layers. Okay, this is the code of building layers. I initialize here. Just see the difference between the first things and the second things. Here the everything is same. Okay, I initialize the layer 1 and I initialize unit equal to 5. Okay, there I initialize unit equal to 1. Here 5. It means my first layer have 5 neurons. I initialize the second layer is layer 2, layer 1 2. Here I initialize the unit is 1. In this layer I have only one neuron. It's a output layer. Okay, I already see. I already said, right. Um, in the real time case, we have a lot of layers, a lot of neurons. Everything you want to initialize, assemble this model, assembling one model. Here inside the sequence I assemble this everything. Okay, layer 1 and layer 2. Normally this kind of things only we do. Okay, this is the overall code. Okay, this is the overall code. I initialize the layer 1 and I initialize the layer 2, and this is the I just given the model name is 2. I compile the model and I fit the model. I predict some things. Okay,